Hey guys, welcome back and let's solve problem 238. Yeah. So product of arrays except self. Wait, so let me just give you a brief introduction what this is saying. Okay, and what is this? Is that we have to convert this array into a new array in which suppose I'm standing at here. So this value would be replaced by 1 into 2 into 0 into 4 means all the values of the array except itself. So it would be 0. Now suppose I am standing at 0. Okay, I am standing at 0. So it would be 1 into 2 into 3 into 4. Okay, would be 8, 24. Okay, so this is the main concept of how to solve. The main thing is let's do the main intuition behind this. What can we do? It of course would like that we can just take a value in which I'm going to put all the sums. Okay, and the moment I have something like I am standing at 1, so I would like r divide by 1, then I'm going to put that. Okay, so this is the math, but this won't go well. Okay, suppose in simple math what we do is if there is a, there is b, there is c, and there is d, and I know the product of a into b into c into d, and I'm asking you, can you find the result in which I have to go for a into b into c? You will be like, yes, we can. We can simply reciprocal this. What we can do is we can divide by c. So c will cut and we got the ABC. But this won't work here. Why? Because this is have some edge cases. This function has some edge cases. Suppose I have c equal to 0. What will be the function? It would be infinity. And I don't want that. Suppose I have 0 here or 0 here. So that would be a little tougher for us. So, and it will not give a pure result. So what we can do, suppose I have 1, 2, 3, and 4. What I can use is I can use a prefix and suffix array. Okay, I'll go for some optimal approach, but for now, let me just go from root to most optimal. Okay, suppose I have prefix, okay, and I have suffix. Okay, now what I will do is I'll keep on, suppose I'm standing at 1. So I'm going to find all the products of values that are before that. And if there's some nothing, then I'm going to put 1. And same like this. Okay, now I'm at 2. So what will the result? It would be 1. I'm at 3. It would be like 2. I'm at 4. It would be 6. Okay, means if I'm standing here, then I know the value of all the products before this is 6. Okay, and same for suffix. Okay, so I'm standing at 4. It would be like, what the value after this? Nothing. So I'm going to put 1. Okay, like this. Now, after 3, what is the value? 4. Before 2, 12. And after that, 24. Okay, now what I will do is I simply make a new array. Okay, in which I am going to protect them. I'm going to protect them. Okay, and I will replace with a new array, and it would be like 24, and it would be 12, 8, and 6, and this is what my answer is. Okay, so this is my approach, but thing is, this is in a good way, but the thing is, it takes 2n complexity. 2n because n for this space and for this space. So I have 2n space complexity. How can we optimize this? So what can I do is, instead of using 2, I can use a simple one array. And what I will do is, let me just go for this. And what I will do is, I'll first find the prefix just as before, but first I'll go in this direction and find the prefix, and then in this array I'm going to store the suffix. And it would be like, what is the value before 1? I'm going to take a variable and like suppose suffix. Okay, I'm going to take variable like suffix, and it would be initial as well. So I am at 4, so I will divide into this with s, and it would result me 6. Okay, so it will be like 6. Now I will then multiply this value with 4 because I'm starting at 4. Okay, then I'll move forward. Now I'm 3. I'm going to into with s. What is s? It is 4. Then 4 into 2, 8. Then I'm going to into with 3. And okay, now I have value of, it would be like 4, 12. So I'm into with s, and it would be 12. Now I will make 2 multiplied with 12 into 24 into s. It would be 24. So this is my modified array. Then I'm going to return this. So in this, I'm using n complexity. But thing is, I'm using this array as my result array. So you can read this. You can solve the problem over extra time complexity. The output array doesn't count as extra space for space complexity analysis. So I can say that this is a space complexity of 1 if I'm excluding the resultant array. But in the previous approach, I am using a n time complexity. Okay. Now, in this, my time complexity is 2n. Okay. I am first iterating like this, then I am iterating over like this. So how can I go for n time complexity and 1 space complexity? And I will be like, let's rethink it. Okay, now let's rethink. What we are doing is finding prefix and suffix. Understood? And I am initializing it 1 and 1 because if I'm standing here, the prefix is always 1. And if I'm standing here, the suffix will always be 1. What I will do is, I'm taking an array, okay, which will always be initialized as 1. Okay, now think. I move to 1. I found the prefix as 1. So I'm going to multiply both of them and put them into this array. It would be remain as 1. So I'm making it 1. Okay. Same with s. What I'm going to do is multiply with this. Okay. No, the thing is, you don't have to multiply with 1 first. What I will do is multiply this first, then I'm going to multiply this with 1. Okay. So the thing is this. I have s equal to 1. So 1 into 1, it would be 1. Now I'm changing this s with 4 equals to 4. And I'm changing this 1 as 1. Okay. Because this into this 1. So now I'll move forward. I'm at this position. What is the prefix? It is 1. 1 into 1, it would be 1. And I'm going to multiply this, so it would be 2. Okay. Now, what is this? 4. 4. And I'm going to multiply this with 4. 4 is at 12. Okay. Now, I'm here. So what I'll do is 2 into 4, it would be 8. And 12 into 1, 12. And I'm going to multiply this with this and 2 with 24. Okay. Now, same, I'm going to replace this with 24 and this this and multiply like this. So this is the concept of time complexity of n and space complexity of 1. If I'm neglecting the return array, else it would also be n because I'm using an extra space return. So let's code this. Let's make it more clear to you by using this. Okay, you will get to know about this. So first let me find the list. Okay, I need a value dot prefix and suffix. That's suffix. Okay, maybe it says well. Okay, now for I in range n. Okay, now what I have to do is I need a resultant array. And I have to return that. Now, what I would do is if I'm standing at I, then I have to into with prefix. Okay. If I'm standing here, then I have to use prefix. And if I'm standing at the back side, then what I'm using suffix. Okay. Now I have to multiply the prefix and suffix with the current values. Screen this up. I have to do is I have to use, if I'm standing here, then suffix would be multiplied with this in the end and suffix would be multiplied with this. Okay? Right. I'm going to do that. PD equals to nums of I and suffix equals to nums of n minus 1 minus I. Okay? Yeah. That's all the code you need to solve this problem. Yeah, it's been accepted as the time space. Let's see. Yeah, it's been accepted. Don't judge on this. It is just a random number that's coming where here. But yeah, you got the point. The time complexity is one for loop and space is only one if I'm neglecting this as it is written. Okay. Hope you understand the concept and how to code, how to make the logic, how to use fixed suffix. If you do, just give it a like or subscribe. It will really motivate me to make people going and educating yourself about how to solve. Okay. Okay. See ya. Have a nice day.